This is day 4 of Unit 4, Section 1. We are still in Section 7.3 in the textbook, but now we're going to look at Part 2. Today we're going to multiply and divide rational expressions. So to multiply rational expressions, we kind of did this a little bit with our exponents the other day. We're just going to turn it all into one big top and all into one big bottom, and then anything on the top can cancel out with anything on the bottom. So here, I'm going to look at this as these two things are all on the top, so I'm going to rewrite it with them factored all the way across, and these two things are all on the bottom, so I'm going to rewrite the bottom factored all the way across. So for this part, I see I have a GCF. They both have a 3x in them, and if I take out 3x from 3x squared, I'm left with x, and if I take 3x away from negative 3x, I get negative 1, and then I'm going to continue factoring. So multiplies to negative 20, adds to positive 1, is x plus 5, x minus 4. So all 4 of these things are part of our numerator. Now the denominator. Multiplies to negative 5, adds to positive 4, is x plus 5, x minus 1. And then I just have 3x as another factor on the bottom. So this 3x up here can cancel with this 3x down here because they're entire factors. This x minus 1 can cancel with this x minus 1. And this x plus 5 can cancel with this x plus 5. So the only thing left is x minus 4. That is our final answer. Nothing else we could do there. Let's look at another one. There's nothing on the bottom here, so I could really think of it as over 1. All right, so the top, x plus 2, there's nothing to factor. X squared plus 3x plus 9. If I tried to multiply things that multiply to 9 and add to 3, it's not going to work, right? Because it's either 1 and 9 or 3 and 3. So that's going to stay as it was. I can't factor that any further. On the bottom, this is an a cubed minus b cubed. Remember, a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So this is an x and a 3 that are being the two terms. So we're going to have x minus 3, x squared plus 3 times x plus 3 squared, which is 9. So now these entire big chunks are going to cancel. They're exactly the same. So I'm left with x plus 2 over x minus 3. So you go ahead and try these two, pause it, and I'll show the answer. All right, so for the first one, on the top, I had a GCF of 2x, took it out, was left with x minus 5, and x plus 3 did not go any further. On the bottom, x squared minus 25 is x plus 5, x minus 5, and then I actually wrote 2x squared to be 2x times x, because I knew I had a plain 2x up here, so I wanted something to cancel. So then my 2x is canceled, my x minus 5 is canceled. On the top, I had x plus 3. On the bottom, I had the x and the x plus 5. Never, ever multiply this back out, right? Keep it in the factors, and we'll call it a day, right? We should not be turning this bottom back into x squared plus 5x. So for number 2, I started with a GCF of x, took that out, was left with x minus 3. This factored to x plus 3x minus 2, and on the bottom, nothing factored, so I just wrote them as two different parts. So then the x minus 2 canceled, and the x is canceled. So I was left with x minus 3 times x plus 3. Again, I'm not going to multiply this out. I'm going to keep it as its individual factors. I'm not going to write x squared minus 9. All right, let's do another one. So this one is just 6. Now we have an a value, so we're going to have to do 2 times negative 18 and get negative 36. We want to add to negative 5, so a positive and a negative, right? So we could have negative 36 and 1, negative 18 and 2, negative 12 and 3, negative 9 and 4. That's the combo. So that's going to be 2x over minus 9 and 2x over 4. Nothing cancels with 2 and negative 9. But this divides by 2, so it's really 1x over 2, so x plus 2. On the bottom, there's just a GCF here. right? 12x minus 54. So I could divide both of those by 6. And 12x over 6 is 2x, and negative 54 over 6 is negative 9, and then times 3x. So the 2x minus 9 is going to cancel. The 6 is going to cancel. So I'm left with x plus 2 over 3x. Another one together. So nothing to do for the x plus 2. It's going to stay. Here we're going to do 14 times 2 and get 28. And we want to add to 11. Right? So 1 and 28, 2 and 14, 3 doesn't go in, 4 and 7. That's it. So that's going to be 14x over 4 and 14x over 7. These both cancel now. This divides by 2, and this divides by 7. So that means this is going to be 7x plus 2, and this is going to be 2x plus 1. All right, this bottom one's going to have to factor 2. So we're going to do 2 times 4 to get 8, and then adding to 9. So 1 and 8, that's it. So we have 2x over 1 and 2x over 8. 2x over 1 doesn't reduce, so that's 2x plus 1. 2x over 8 divides by 2, so that's 1x over 4, x plus 4. And then I have this other factor by itself, 7x plus 2. So 2x plus 1 is going to cancel with 2x plus 1. 7x plus 2 is going to cancel with 7x plus 2. And I'm left with x plus 2 over x plus 4. You go ahead and try both of these, pause it, and I'll show the answer. All right, so number 3, we have our full factorization, 2x plus 1 times x plus 7 times 5x plus 1 over x minus 9 times 2x plus 1 times 9 times 5x plus 1. So we had 5x plus 1 canceled. We had 2x plus 1 canceled, and we were left with x plus 7 over 9 times x minus 9. And then in 4, the full factorization on top was 7x minus 6 times 3x plus 5 times the GCF of 7 times 2x minus 1. And then 2x minus 1 times 7x minus 6 times the GCF of 9 times 3x plus 5. So this 7x minus 6 canceled with this. This 3x plus 5 canceled with this. 7 had nothing to cancel with. This 2x minus 1 canceled with this. So I was left with 7 over 9. All my x's went away. All right, so that's multiplying, and dividing is almost exactly the same. For dividing a rational expression, if you think about what we did to divide fractions when we were learning about algebra, you multiply by the reciprocal. So that's what we're going to do. If I started with a over b divided by c over d, I'm going to turn it into multiplication, and I'm going to flip the second fraction over to get the reciprocal. And then it becomes a multiplication problem. So here, we kept the first one the same, changed the sign, and then flipped x plus 2 over 2x minus 3 to become 2x minus 3 over x plus 2. So let's find each of these quotients. So this I'm going to keep the same. I have 7x over 2x minus 10. I'm going to turn it into multiplication, and now I'm going to flip this over. X squared minus 11x plus 30 over x squared minus 6x. Now it's a multiplication problem. Now I'm going to focus on factoring each one. So the top, 7x nothing does. 30 multiplies 30 adds negative 11 is x minus 6, x minus 5. My bottom, there's a GCF here. 2 comes out, and I'm left with x minus 5. And then there's another GCF here. That's an x. And if I take this, x minus 6. So we have x minus 6 that can cancel, x minus 5 that can cancel, and x with x. So I'm actually left with 7 over 2. I do want to point out, based on the original problem, the values that would make this denominator 0 aren't allowed because you can't ever have a fraction that was equal to 0, had 0 on the bottom. So the numbers that would have made the bottom 0 are based on this over here. So x could not have been 6 and x could not have been 5 in the original problem because that would have made this denominator 0. All right, let's look at B. So I'm going to keep the first part the same. Times, now this was really over 1, so now it's going to be 1 over 3x squared plus 5x. So factoring this part, 6 times negative 15 is negative 90. You want to add to a positive 1, so that's negative 9 and 10. 6x over negative 9 and 6x over 10. Both of those reduce. So that's going to become 3x minus 2 times 3x plus 5. Oh, something happened. 2x minus 3. Wow, what happened there? And 3x plus 5, and then times 1, so I don't have to write anything else there. This is 4x squared, and now there's a GCF here, right? And 3 and 5, nothing comes out, but they both have an x, and I'm left with 3x plus 5. So here, the only things that are going to cancel are the 3x plus 5s, so I'm left with 2x minus 3 over 4x to the third. And this didn't have a denominator, so I don't have to worry about anything here, right? I'm not going to have to account for it right now. So you go ahead and try these two. You don't have to tell me what x can't be, but do simplify, find the quotient. Pause it, and I will show the answers. All right, so number 5, I end up with 4 over 5 because x minus 4 cancels with x minus 4, x minus 2 with x minus 2, and this x here with this x here. So just 4 over 5 is left. And in number 6, the 2x plus 5 here cancels with the 2x plus 5 here. So the top I'm left with x minus 1, and the bottom I had 6x times x. This is the only time we're ever going to actually multiply them and write 6x squared. All right, we're just going to continue. These problems are just a little trickier, but nothing is different about what we're doing. All right, we just have a lot more going on. So let's flip it first. All right, still finding the quotient. So the first fraction gets to stay the same. Now it's going to become times, and the 6x minus 8 is going to go on top. And the 3x squared minus 22x minus 80 is going to go on the bottom. So there's a GCF in the first set. All right, we could take out 9 and x. So 27 over 9 is 3. 72 over 9 is 8. And here I have a GCF of 3. And when I take, oh, sorry, 2. Wow. And when I take 2 out, I'm left with 3x minus 4. So that's my whole new top, my whole new numerator. For the denominator, I have a GCF here as well, another 9x. So that's going to be 3x, and then negative 36 over 9 is negative 4. And now this one I actually have to factor. So 3 times negative 80 is negative 240. All right, negative 240. I can go through the whole list here, but it's going to be 8 and negative 30 equals negative 22. So that's going to be 3x over 8 and 3x over negative 30. Nothing to reduce there, so we're going to get 3x plus 8. This one divides by 3, so it's 1x over negative 10, or x minus 10. So this 3x minus 4 cancels with this 3x minus 4. This 3x plus 8 cancels with this 3x plus 8. And this 9x cancels with this 9x. So I'm left with 2 over x minus 10. One more together, and then you could try the last two. So 7 times 100. Hold the phone for a second. All right, I'm good actually. So 7 times 100 is going to give me 700. So I want to add to 80. So that's actually going to be 70 and 10, right? 70 times 10 is 700. 70 plus 10 is 80. So it's going to be 7x over 70 and 7x over 10. This one divides. Oh, we forgot to flip this first. Sorry, guys. Let me rewrite it first. Got so distracted by that 100 there. Okay. So now, when I'm rewriting the top here, 7x over 70 we said divides by 7, so it's x over 10, x plus 10, and 7x over 10 does not reduce, so it's going to stay 7x plus 10. This has a GCF of 3, and when I take out 3, I'm left with 7x minus 3. For the bottom, we're going to have to do 49 times negative 30, and we do that, and we get negative 1470. Right, really big number. We're looking to add to 49, positive 49. So one's positive, one's negative, and we can really go through that whole list there, but it ends up being negative 21 and 70. So that means we're going to have 49x over negative 21 and 49x over 70. So this divides by 7. This also divides by 7. So this is going to be 7x minus 3. This is going to be 7x plus 10. There's a GCF of 3 in this problem, and I'm left with x minus 8. All right, so we have a 7x minus 3 to cancel, we have a 7x plus 10 to cancel, and we have a 3 to cancel. So my final answer for this one is x plus 10 over x minus 8. You can go ahead and try the last two. 8 is especially difficult because of the reverse order here. So if it makes you feel better to write negative 16x plus 72 as your top part there, that might help you out. So go ahead and give them a try. You can pause it and I'll show the answers. All right, for number 7, this factor to x minus 7 times 3x minus 5. This part, which is now on our top, factors to 3 times 7x minus 9. The 63x minus 81 factors to 9 times 7x minus 9. And this, which is now in the denominator, is 3 times 3x minus 5. So we get 3x minus 5 to cancel. We got 7x minus 9 to cancel. And we have 3 to cancel. So we're left with x minus 7 over 9. And then in our last one, right, I said we flip that around so we could actually take out a negative 8. I'm left with 2x minus 9. This part down here, which is now the numerator, factors to 5x minus 4 times 2x plus 5. So 8x plus 20 is really 4 times 2x plus 5. And this part up here that's now in the denominator is 5x minus 4 times 2x minus 9. So the 5x minus 4's cancel. The 2x minus 9's cancel. 2x plus 5's cancel. I'm left with negative 8 over 4, which reduces all the way down to negative 2. And that is the end of our lesson 7.3.